Hi everyone, and welcome to SETI Astro. Today I'll be showing you my basic workflow to use Narrowband data, Continuum Subtraction, and RGB data to end up with a final galaxy with the Narrowband Continuum Subtracted data layered onto it. I have the Narrowband and RGB masters open. And off to the right, I have a bunch of various process icons that I've kind of gathered over the time. I will have a link if you want to download them and use them for your own purposes as well. I just start out by relabeling all the masters. Alright, now that they're all relabeled, I also like using an image container. It makes some of the initial processing less tedious in my mind. I have a GracXpert script already set up, so you could just drag and drop and we'll let GracXpert run. Okay, GracXpert's done running. The next step I do is BlurXTerminator. I have 3 saved settings in BlurXTerminator, kind of a default, an aggressive BlurXTerminator, and then one that'll do fluffier halos. I find the fluffier halos actually work the best with StarXTerminator, so we'll run BlurXTerminator with the fluffier halos. Is finishing up. Next we'll do StarXTerminator. Just drag and drop it on the image container. And we'll be back when StarXTerminator finishes. Okay, StarXTerminator is done, and we'll go ahead and minimize all our stars. Just kind of drag them to the side for now. The other thing to check really quick is how well the stars were removed, and if you have to utilize a clone stamp to get rid of any of offending stars that weren't. So here is one that wasn't removed properly, and we could use clone stamp to get rid of that. Okay, that's done there. The next is probably the part most people want to see, and that's continuum subtraction. Methods for continuum subtraction. The one I use, I think, is the most data accurate out of all of them. What we're going to do is take the narrowband data and put that in the red channel, and then the broadband data in the green and blue channels, normalize all the data, and then essentially take only the data that's the outlier in the red channel and make its own image from that. So we'll walk through the process. The red broadband data and the hydrogen alpha data, we'll use channel combination. The next thing we need to do is normalize the data. So we'll need 2 previews. The previews on one of the other images first, and then dragging them over to the combined. We'll need one for the background and one for the core. Do background neutralization. And then we're going to use color calibration with no structure detection. And the region of interest, we'll use our previews. Now that we're normalized, we should be able to do a screen transfer stretch. And now you can really see all the hydrogen data itself is in red, whereas all the continuum data is just broad white. So what we'll have to do is extract that red out. And in order to do that, I have a script down here for pixel math, and we'll just run it. And do an STF, and there is our continuum subtraction hydrogen data. Go ahead and close this combined image, and then we'll have to do this again for sulfur using the red as the broadband channel, and then for oxygen 3 I use green. So we could run through oxygen 3 quickly, and I'll show you that process to ensure everybody has it. Again, we'll use channel combination. We'll put the broadband data in the green and blue channels and the narrowband in the red. Generate the image. And then we'll want our previews, one for the background, one for the core. We'll do background neutralization first. Color calibration with no structure detection. Now if we do the STF, here is the oxygen data, and now all the red chunks in here are our oxygen data. We'll do the same continuum subtraction pixel math. And do an STF, and here's our oxygen data. Continuum subtracted. And I'll do the same now for sulfur. Okay, we now have our 3 continuum subtracted narrowband channels. Here's sulfur, hydrogen, and oxygen. Next to do is permanently stretch and combine them. Just for the initial stretch, I'm usually okay with the current stretch that STF does. In order to make it permanent, I just use the check button here and then drag to histogram transformation for each one. And then combine them into whichever palette is most suitable for the object you're using. For this one I did HSO. And now we should apply some noise reduction. I use RGB. And now it's a matter of adjusting the colors how you want for your palette. If you want to be more scientific about it, you pretty much end out around here. If you want to be more artistic, that's when you could play with color masks, other masking, and stretching channels independently of each other. I'm always on the more artistic side of these images, so I don't have any problems with utilizing like a yellow mask. And applying that and adjusting curves. Maybe a little contrast. Little increase in the chrominance. And I'm not a big fan of some of the greens out there either. And there's not a whole lot on the green mask, just near the core. So I'm just going to use SCNR. And there's these purpley magenta colors from where the oxygen and the hydrogen are overlapping. So maybe we want to bring that into more of a blue. Let's see how that looks. Yep, and you can see it brought a lot of the blues now. And then we're probably going to want to heavily adjust this as far as contrast is concerned, because when we end up screening this back with the RGB data, all this bright outside would come across as well, and we essentially want everything that's not narrowband to be almost zero. So a good way to do that is just start out with histogram stretch and just bring the black point down to your clipping some. It's getting better. Good look at some curves just to bring out some of the structures in here again, because those will have to be fairly bright. But again, we don't want a whole lot of increase in this area. To have to adjust curves a little bit more to even bring down the background even further. Really don't want a whole lot of background at all. And you can continue playing with these until you get to where you would like. We'll call this our HSO. And now we will move on to our RGB really quick. For RGB, I didn't do anything too fancy. I believe just combine them in your normal RGB. And I know a lot of people will use SPCC for color correction. Since I was putting so much narrowband data into it anyways, I'll just correct it very similarly to how we did our narrowband continuum subtraction, which you could use background neutralization and color calibration to get us pretty close to a normal RGB. And here's just the STF of the RGB data. And we'll go ahead and give it a permanent stretch. And do some curves adjustments as well, just to bring out the galaxy a little. Not bad for a first pass. Another item I like doing is ensuring that we can get rid of these green splotches. Just run a quick FCNR. And I do like the dark structure enhancement. I find that its default setting is a little too strong usually for my taste, so I bring it back down to about 0.2. And we'll come back when that's done. That done, we can go back and forth to see what it does. In these darker layings, you'll see it darkens them up nicely. And for the time being, I think we'll just leave the RGB data at this and go ahead and screen it with our narrowband data that we have stretched and continuum subtracted out. So we'll call this our RGB, and here's our HSO. And screening them together, you could either use Pixel Math, or there's the toolbox now. Whichever method you really prefer. And there's our nebula now on top of our RGB data. And maybe we'll just run a little bit more curves to bring out some of the other contrast against the background and the main part of the galaxy. Another thing I like doing, I don't like a whole lot of additional color out in the background space, so you could use mask range selection. And find what you think is appropriate for the range that you want to adjust. And you can put the mask on. Control-Shift-I will invert the mask. Like I said, we're just going to mess with the saturation on the outside there a little bit and reduce some of that saturation down. Well, we got this particular mask on. Maybe you want to play with local histogram transformation. So we'll Control-Shift-I again to now select the mask for the interior. And we want a broader something like that. We could execute that. Alright, that's done. What we're also going to utilize this mask for is when we bring the stars back in, we don't want the stars as prominent in the galaxy itself. So we could do pixel math. And let's say we want the stars roughly 25% less than they would be otherwise. We inverted the mask. Now we're just going to add 0.75 to every single pixel on here. So it's really just going to take this black and move it up to 0.75. And that's going to be our mask for the stars on our combined image. And now to deal with the stars. Unfortunately, I do have an achromat refractor, so I have very bad blue star bloat, and I hate using my RGB stars. Because of that, I almost exclusively use narrowband stars, which a lot of people don't utilize, but there's a great script called the 4x palette utility where it will generate stars for you with your narrowband data. It'll also generate your 4x script for your narrowband data, but we have been using our Continuum Subtracted data. We might as well see what the 4x palette looks like. So now we have our Continuum Subtracted data over here and our stars on the right, and just tell it to execute. Alright, we have stars, and this is what it came out with the 4x palette. There's a lot of these burnt rust orange colors and blues, which sometimes is really good, which is a really good palette too for a lot of our narrowband targets, but I'm not going to utilize that. It also has a couple of masks and images it used. But now for the stars, I just use histogram transformation and give it a couple pulls to the left here on the midtones. Usually 3 or 4 of those, and then final tweak to the star level that you really want for brightness. You could zoom in, and if you want a little bit more color, you'd always just do color saturation. And those are our stars. So now we'll go ahead and screen our stars back with this image, with this mask applied to the image. And you're going to have to replace this image with the mask on in order for the mask to be applied. And now our stars are screened back in there. And it is a matter of flipping the orientation on this particular object, which can be done in geometry, rotate 180. And there you have it. A RGB and narrowband continuum subtracted final image. Now obviously you could spend a lot more time bringing out details in oxygen or sulfur or any of the other channels. This has been just a very quick workflow set of instructions that I roughly followed for this object. There's a lot that can be done to bring out some of the dimmer, broader structures over here. You can see in oxygen over here, there's some around the core structure as well. We could have did a little masking and adjusting of curves there prior to bringing it across into the RGB data, but this should give you a nice broad idea of my workflow and how I go about processing narrowband into RGB. I hope you like the content. If you have any questions, please leave a comment down below. Please like and subscribe.